Hello Pre-Calculus, I've got a new video for you. It's kind of complex, but I've got a few different approaches for how to graph this, so there might be more than just a few videos on this. Maybe two, maybe three, we shall see. All right, so graphing logarithmic functions. Here's the deal. We must understand that logs and exponentials, okay, I'm going to put logs because they're logarithms, and exponentials, those two functions, so log base 2 of x versus 2 to the x are inverses. And what that means is that if I were to take y equals 2 to the x power and try to determine the inverse of it, I would switch out the x and the y. And I'd have to solve for y now. And here's the thing. The result of that becomes log base 2 of x equals y. Now today I'm not going to show you all the computational gymnastics you have to do to get from here to here. That's just not my intention today. My intention is for you to understand that inverses swap out the x's and the y's. So if I want to graph log base 2 of x, all I got to do is graph 2 to the x power and then flip the x and the y values. So I'll show you how you can do graphing in this context of just the swapping, and we'll see where that takes us, okay? So strategy number 1. And I like this strategy because it forces us to recognize the relationship between logs and exponential functions. The reverse of log base 2 of x is, we're going to do a table of values for y equals 2 to the x power. So just do a regular -2, -1, 0, 1, 2 table. I just know anything to the 0 power is 1, so I'm going to start there. 2 to the 1 power is 2. 2 to the 2 power is 4. Now what's 2 to the -1 power? Well, what it does is if it's a negative exponent, that's just the same as putting it in the bottom part of a fraction. So this is going to be 1/2. Your calculator will confirm that. And then this is 1 over 2 squared if it's 2 to the -2 power. So that's the same as 1/4. So this is the table of values that produces our exponential curve y equals 2 to the x. Okay? Now, you are literally reversing the x and the y values to graph log base 2 of x, because the inverse function is the x's and the y's are switched. So I'm switching the x and the y. So instead of having a horizontal asymptote at 0, I now have a vertical asymptote at 0. Everything was forced above. Now everything's forced to the right. And now my x-coordinate is 1/4 of a unit I'm going down to. Now my x-coordinate here is 1/2, go down 1. Over 1/2, down 1. My x-coordinate is 1, my y-coordinate 0. Over 1, up 0. x coordinate 2, you get 1. 2, get 1. X coordinate 4, you get 2 out of that. And this is the log pattern if its base is 2. And it continues to go like that, and it never goes left of the y-axis. So this is the graph y equals log base 2 of x. And just keep in mind that it is the inverse of 2 to the x power, which looks like this. Right? It has that visual symmetry about the y equals x line. Now, I'm not asking you guys to graph the inverse function. I just thought it would be cool to kind of see like, okay, that's log base 2 of x. Here's y equals 2 to the x power. And one way to graph them is to just graph the opposite of what the original gives us. Now, I'm going to say this much. It's not always that simple, okay? Like this was a straight up cookie cutter white bread log base 2 of x. There was no horizontal shift. There was no vertical shift. There was no horizontal reflection. There was no vertical reflection. What happens when we get those pieces in a log function? I'm glad you asked. Because the first one given, or the second one given, gives us a vertical reflection. The negative on the outside, if you recall from the previous video, means a vertical reflection. So let's think about this for a moment. If the log has a vertical reflection, and I'll put log in quotes, I'm talking about the logarithm, then the exponential function, I'll just call it exp, has a blank. If the log has a vertical reflection, then the exponential has a Is the answer vertical reflection? Is the answer the horizontal reflection? Well, this much I can say. Solving this equation would put to rest exactly what's going on. I'm not showing you guys how to do this yet until we have a firm sense of the graphs. But what I can tell you is the solution to this equation to get y by itself is y equals 2 to the negative x power. That's a horizontal reflection. Okay, so the reflections get reversed over inverses. And that made sense. We had a horizontal asymptote on number 1 here, which turned into a vertical asymptote here. So all we got to do is ask ourselves, what's the table look like for 2 to the negative x? So we're keeping these values. If I plug in negative 2, that gives me 4, because it's negating a negative. If I plug in negative 1, it gives me 2. If I plug in 0, it's still 1. If I plug in 1, now it's 2 to the negative 1 power. It's a half and a fourth. Okay, it reverses everything so that the function comes down first as the exponential. Now, if it's a log, we're reversing the x and the y coordinates. So what I'm doing is I'm plugging in 1, 2, 3, 4, negative 2, 2, negative 1, 1, 0, 1/2 1, and 1/4 2. Okay, so just like this one still had a horizontal asymptote at 0, this one's still going to have a vertical asymptote at 0. But it's going to climb up this way. So this is what happens when you get a log that has a vertical reflection. Instead of moving up like it did on number 1, so check out your graph for number 1 to figure out that it worked like this. Now it's flipped. Okay, it's not coming from negative infinity now, it's coming from positive infinity. This is kind of cool if you don't understand it. Totally bewildering if you don't know what you're doing so far. All right. The log is given a, from yesterday, you know that inside the parentheses, if there's a negative in front of the x, that's a horizontal reflection. For the exponential, it reverses. Now it's a vertical reflection. What does a vertical reflection look like for an exponential? That looks like the base now has a negative in front of it. So what we're doing is we're saying, what are all the points that would be given for negative 2 to the x power? I believe I'm running out of steam with that. Let's see if we got some more. Oh, nice. Okay, so when I plug in negative 2, that negative will forever stay in front of the 2. So it's going to be negative 1/4. This will be negative 1/2. This will be negative 2 to the 0 power. 2 to the 0 power is 1. Negative 1. Just like this one. 2 to the 1 power, 2. Negative 2. 2 to the 2 power, 4. Negative 4. I know sometimes students will try to say, Mr. Owsley, it's negative 2 times negative 2. No, it's not. That's negative 2 times negative 2. This right here is the negative version of 2 times 2. Anyway, so you can plot these points to graph your exponential, but we don't want to graph the exponential. We want to graph the log. So we're going to flip the x and the y coordinate. You're going to go left a quarter, down 2. You're going to go left a half, down 1. Left 1, down 0. Left 2, up 1, and left 4, up 2. And then, just to show you that this pattern keeps extending, if I plugged in a 3, I'd get negative 8. So if I went left 8, which is one more box here, I'd go all the way up to 3. There's an infinite number of points that continue going this way. So we still have an asymptote at y-axis because this has a horizontal asymptote as the x-axis. So you're not going to go, in this case, to the right of that axis. It's going to get infinitely closer. All right, so we just hit the 15 mark on this video. I think the first 3 examples, this would be a good place to just stop, maybe just kind of like catch your breath, see if you can work on a few examples on the homework that are relatively basic, and then come back to the video and watch the last 2 examples. Because the last 2 examples, we're going to be throwing some horizontal and vertical shifts in there, and gets a little bit hairier. Thanks for watching.